First of all, these are power supply, as you all know. Then we have function generator. Then we have our main circuit here. Then we have CRO, and as well as our AC multivoltmeter. So first of all, we will connect one to one carrier signal and two to two. One to one, two to two to two. Okay. Then what we will do? We will give our input wave.
This is function generator.
From the function generator. See here wire where is coming from. Function generator, here its wire is going from function generator. We will be in positive to 3. See here, positive to 3 and negative to 4. It's our input. Then with input we will connect our AC millivoltmeter. Same with 3 and 4, we will connect our AC millivoltmeter like this for changing the amplitude or frequency. Here now our input is done completely. So now for taking output we will connect, see here, from CRO. See, from CRO wire we will connect
to 5 and 6
to 5 and 5 connect ho jaye 5 and 6. So now it's connected.
CRO is connected, all connections are connected. Now we have to turn on the circuit.
Yes, DJ starts. So now all circuits are on. This is our first table. What we have to do, we have to first fix the frequency.
First of all, we have to fix the frequency to 500 hertz.
Okay, I am
using
changing
frequency variable.
Frequency variable, you can see here. Frequency is changing. 500. Come on. Okay, let's consider, for example, it's 500 hertz. Now for 20 decibel attenuation, let's see our analog. It's in the range is 1 volt, so we will set it to approx 3. Sorry, I am
340 volts, millivolts we have to set in AC millivoltmeter.
So 340 approx. It's wait. It's very, yes, it's 340 now. Okay. After applying our voltage to, you can see that 1 volt is here range, and here you can see it's 340 millivolt. So after applying 340 millivolt input, we have seen that this is our output. Emax is this, Emin is this. We can calculate Emax and Emin, and by which simply we can calculate modulation index N.
Now for the first part, we have to fix our amplitude to 340 millivolts, and we have to vary frequency from 20 hertz to 2 kilohertz.
Okay, so I am reducing the frequency, as you can see here. और अगर आपको नहीं दिखता तो मुझे कोई फर्क नहीं पड़ता. So for example, I am taking 76 hertz. Let's take 76. 76. Oh my goodness. ये तो डांस ही डांस कर रहा है. Wait. Come on. Yes.
This one is perfect.
Okay. For 70 hertz, this is our Emax and Emin. Okay. Now we will increase, and let's see. Let's see. For example, I'm making it 150 or 200. Let's see how it changes our amplitude. Okay. So this is our new wave. So we can calculate this Emax. What happened?
Just increase this.
Increase the. Wait. Let's see.
Some noise is there.
Some noise. Okay, so if you want to note the Emax and Emin, just simply stop it. Then, as we can see here, we can move it up or down. So simply for any reference line you can take it as like x. I am taking it as from here. So as you can see, we have how many columns? 1 2 3 4 4. Simply 4 multiplied by the voltage, it's half. So 4 into half, it's 2 volt. And for this we can see it's approximately, we can move it by position back here. And
we have to note E minimum now.
Yes, E minimum. For E minimum, I'm putting it on min position and then here. So make it like this so that you can observe clearly. So as you can see from here, it's approx 0.4, 0.4. So 0.4 is E min, and 0.4 but multiplied by half factor, so it's 0.2. It's 0.2, 0.4. Again, I'm repeating, it's 0.4, but multiplying by half factor, so it's 0.2. And we have 4, but multiplying by half factor, so we have 2. So 2 E max and 0.2 E min. We will put it on our formula and we will get our modulation index.
One important thing is that we have to check that the modulation index should not be greater than 60.
Yes, it should not be greater than 60 or less than 45. So sorry, it can be less than 145, but from the table you can see it started with
this one is first.
Okay, this one is first. From where? Yes. For fixed amplitude 340, it has started with 52.4, 52, 52, 52, 50, then 41, 41, 33. It goes up to 33.
First reading was since 62, so we have to remove that reading.
Yes, we cannot exceed beyond 60%.
In this video, we'll show how to trace the all the modulating, carrier signal and demodulated wave.
So first of all, we will connect 1 to 1 and 2 to 2. That's it. 1 to 1, 1 to 1, and 2 to 2.
Yeah, that's fine.
So for carrier wave, for tracing carrier wave, we will connect our
channel 1
oscilloscope simple to our
1 and 2.
1 and 2.
And make sure that red is connected to 1 and black is connected to 2.
Okay. So now here you can see
we can now adjust it.
And this is our carrier wave, and as you can see, frequency is, it should be in kilohertz, either 120, 84, but it should be in kilohertz. You can reduce it
like this. We can
and we can
this that three wavelengths are visible.
So we can trace it. It's our carrier wave. Okay. So carrier wave is done. Now I will remove this from here. So for measuring
modulating and modulated wave.
So first of all, we will give our input here from oscilloscope.
Oscillator to 3 and 4.
3 and 4. Then and we will get our modulated wave here at 5 and 6. So we have to trace input wave, this wave, and modulated wave from here. So we need 2 wires in oscilloscopes. So first wire I will connect into input. So I'm connecting into input. Here, as you can see, positive to positive, negative to negative, and then
now we'll connect the second channel of CRO to in order to trace modulated wave.
Modulated wave, second channel of CRO, and it will be connected in here in modulated output. So it will be 6. So as you can see, one is from modulated, one is input. So you can see here, adjusted. Here, as you can see, we have our
increase the frequency.
Actually, you can please increase the amplitude so that we can get better amplitude.
So we have to, I think, attenuate it.
Attenuation. Yes, attenuation.
See, now we are getting perfect.
Yes.
This one is perfect.
This one is perfect.
The upper one is input wave, and this one is modulated.
Modulated. So is the input. This is pink one is modulated wave, and x1 pink one is
Yellow,
modulated,
yellow one is input wave.
yellow wave is input wave. So input wave and modulated wave are done. For demodulated wave, we need to take out all the CRO wires. Input wave, let's keep it input there. For demodulated, we will connect our
5 to 7 and 6 to 8.
5 to 7 and 6 to 8. This will send our modulated wave to demodulating circuit, and we will
And
simply
here we will take the output.
We will take output
For
here
demodulated
for demodulated wave at 9, positive of 9 and 10. So here our pink wave is demodulated wave, and our yellow wave is as earlier input wave. So demodulated wave will be like this, little bit noise will be upside. So this is demodulated wave, and input wave will be like this. So we can trace both or either only demodulated wave.